Okay, so right now when we run this thing, we have, if you're using the model that I have, what you have is a situation where we have these things starting within the 500 by 500, but over time they diffuse in a way that would warm a physicist's heart. So there we go. So we don't want this. We want them to stay within it. So tell me where I would go to change this. Okay. So associated with their motion, and where in their motion? Aha, yes. So here, when they come into motion, here we have this move to this place, right? So here, we're moving to a location which is based on our current location. Rather than trying to move to any old location and then trying to somehow intercept our stuff ourselves, try to wake up on the way to figure out if we're going into a bad territory, it's much better to head that off up front. So one thing we can do here is we could say, so double x, so this could be x the destination x equals, and we'll start with this to be sure, but we'd rather do a maximum of 0. So if this is negative, we'll have 0, and a minimum of 500. So if this is greater than 500, we'll use 500, and we could have that for the destination x and destination y, right? Eh? Okay. Now, this actually is bad practice. It's not so great practice. What's going on here? Why not? What am I hard coding?
500?
Yeah, this 500. I'm hard coding. How could I find out the actual width of the space? Yeah, this dot get main dot environment dot, and we could go see get height. Okay. Get width, and this dot main dot environment dot get height, right? So if you decided later to go modify that, you could do so. Okay. Yes.
Would it be, like from a performance perspective, you want to just put that as a parameter? Because that's not going to change in time, right?
What's not going to change in time?
The dimensions of the
Right.
environment.
Yes.
Instead
of calling it every time, you're saying, yeah, you could set it to be I mean, if you wanted to remember it, so when the agent gets created, it remembers the width of that space or the height of that space. But probably this is not incredibly, it's probably not incredibly expensive at all to do. I'd say it's actually less expensive. Probably a lot less expensive than asking who's the nearest neighbor, for example. Okay, so folks, do people understand the logic of this? So, look, if that x location is bigger than the width of the space, you want to limit the value to that edge, that width of the space. If that location is less than 0 that you get, you want to limit it to 0. Okay? So we should be able to see a situation where we get diffusion, but the diffusion now is bounded in a way that may also warm a physicist's heart. See that? What is the impact of bounding it? In terms of infection spread, what's the impact of bounding it?
It keeps something constant, like the influence of the disease. The density of the people are constant.
Yeah.
So
right.
It allows you to track something over time.
Right. Okay. So that's good. It among other things, it means that, well, let's put it this way. The effects of the infection are more keenly felt, more closely felt. Because if people are diffusing way out, they may never encounter each other. They'll just go way out, and one person may be infected, but he's so far from the others. Over time, people are just getting further and further from each other. Here, in a defined space, ladies and gentlemen, people they're not over time getting further and further from each other. They're staying within some average amount of distance to each other. And so it kind of normalizes the situation over time. Okay, so this would be